some areas, some soil have been given the term problematic soil. This is because they are troublesome to be used as a base for any construction or foundation due to factors such as soil movement, which can cause excessive settlement. One of the examples of this problematic soil is peat soil. Peat soil is known to have a high quantity of organic matter. This causes peat soil to be unfavorable when it comes to construction, as it has high water content, low bearing capacity and high compressive rate. So soil improvement must be done, and one of the examples of soil improvement is using geosynthetic materials. Geosynthetic materials has a wide range of construction uses, either to be used as reinforced soil or to stabilize a slope. Examples of geosynthetic materials are geotextile, geogrid and also geomembrane, each with its own function and capabilities. Soft soil have been a major problem when it comes to construction. Soils like peat soil have high water content, which makes it difficult for construction of embankment. According to a study, it shows that peat soil located in areas such as Kalimantan has a high water content ranging from 250% to 400%, and it can even go up to 600% of water content. Another issue regarding peat soil is its high compressibility, which requires high volume of backfill to ensure no excessive settlement. Peat soil has also low bearing capacity, which also causes excessive settlement. Therefore, when embankment is constructed on top of peat soil, the road might have some cracks and also be uneven. This will cause harm to the road users in the future. So further studies need to be done to better understand the characteristic of peat soil and also find out the appropriate solution. The aim of our study is to review case studies of design principles and application of geosynthetics on soft soil. Therefore, we have two main objectives. The first one is to study the characteristic of soil that requires reinforcement by using geosynthetic materials, and the second is to study a suitable design and principle of geosynthetic material use.
From the previous study, the geosynthetic product is GEOGRID, which is the GEOGRID can improve and increase the stiffness and the load carrying capability of the soil by less friction between the soil and the geosynthetic, which is the GEOGRID. Next, the GEOGRID opening should be large enough for aggregate and soil to penetrate and interlocking with the GEOGRID materials. Next, for the geosynthetic product is made from the polymer materials when used for reinforcement or soil improvement purpose. Okay, from the previous research that tell us in the Brazil, which is the GEOGRID reinforcement is below the embankment and the top of the soft soil, which is the soft clay, sand and the medium clay, which is stated at the right at the left side. Alright, for the next literature review, which is from Locke at 1994, that describe the failure of the two geosynthetic reinforcement embankment, and one the unreinforced embankment, and the second one is reinforced embankment, which is the unreinforced embankment is collapsed at the 4-meter length, and the reinforcement embankment are collapsed at the 6-meter.
GeoGrids are used to provide solutions when engineers encounter unfavorable soil conditions by allowing a reduced thickness in a pavement structure by stiffening the subbase. So this figure shows the potential applications of geosynthetics in a layered pavement system. As we can see, the base reinforcement is used for pavement roads and is typically applicable for low volume roads founded on weak subgrade, and the reinforcement placed within asphalt layers are used to reduce fatigue, thermal and reflective cracking and control rutting. Other than that, type of geogrids used are also important to improve the performance of the subgrade soil. The interlocking between the geogrid and base course aggregate results in reduced lateral movement of the base course aggregate. So the geogrid that is suitable to use as reinforcement is biaxial geogrid. So this type of geogrids has good bearing capacity and can improve the long-term durability of subgrade and greatly reduces road maintenance costs. The geogrid material is polypropylene. The table shows the biaxial geogrid properties. These properties are very important for the geogrid to act as reinforcement. The aperture size should be large enough so that the aggregate and soil can penetrate and interlock with the geogrid. Next, the grid thickness applies for both the rib and the junction thickness should be thick enough and adequate rigidity to allow strike through of surrounding soil. The flexural rigidity is the resistance of geogrid when undergoing bending. Other than that, the tensile strength is also important as it is maximum resistance to deformation developed when it is subjected to tension by an external force.
From this study, the issue of the soft soil at the road embankment, which is the PEAT soil, are countered by the laying of the network of the timber trunk. In the past studies state that they are using the traditional system which are corduroy foundation, and this method are not really eco-friendly. So the layer of the timber trunks is depending on the peat soil compressibility, and if the compressibility of the peat soil is high, so the layer of the timber trunk is needed also high. And the geosynthetic product that have been chosen to replace the corduroy foundation system are GEOGRID, and the GEOGRID are very function in improving the soft soil by preventing the local shearing of the subgrade and improving the load distribution to the base course and reorienting the subgrade shear stress. And the advantage of the geosynthetic product instead of the timber trunk method are to keep the road embankment backfill are thin and light as possible while improving the subgrade layer. Other than that, the method also could prevent the environmental sacrifices where tree will be safe, and the geosynthetic reinforcement system could result in 40% project cost reduction.
So for conclusion, soft soil which contains of high moisture content, high quantity of organic matter and also low bearing capacity of soils are the characteristics of soils that require reinforcement by geosynthetic material. GEOGRID that is suitable to use as reinforcement is biaxial GEOGRID as it has good bearing capacity and can improve the long-term durability of subgrade and greatly reduce root maintenance costs. The aperture of the GEOGRID allows the interlocking with surrounding soil and perform functions as reinforcements. For example, taking a study of road embankments on PEAT in Kalimantan shows that where geogrids are laid over the low embankment made of PEAT to provide stability of the road embankment. Comparison of geosynthetic product and a conventional material applied before, which is laying of timber trunk, shows that geosynthetic product keeps the road embankment backfill thin and light while improving the subgrade layer. Thus, objectives of this study have been achieved.